All right, so here we have a right triangle with side length 6, 8, and our hypotenuse is 10. What we want to do now is find all 6 trigonometric functions of this right triangle in relation to our angle theta. So our first trig function of theta that we are going to be solving for is going to be sine of theta, and then we'll have cosine of theta, and then third we'll have tangent of theta, and then we'll focus on the inverse function. So the inverse of sine we know is cosecant, and then for cosine, the opposite is secant, and for tangent, the opposite is cotangent. So now we have all 6 of our trigonometric functions in relation to theta. We have sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. So now we're ready to begin and solve this problem. Our first trigonometric function is sine. So for sine, another way we can refer to sine is SOH. So SOH. And then if you write it as a fraction where we have O over H, our O is our opposite side length in relation to our theta angle, and our H is our hypotenuse, which is always the longest side length. So, and again, opposite or the inverse of sine is cosecant. So basically, to do the opposite and take the opposite of sine in relation to writing it as a fraction, we're just going to write the reciprocal. So we're just going to flip the fraction, and instead of opposite over hypotenuse, we have H over O. Again, H represents hypotenuse, which is always the longest side of the triangle, and our opposite side is just the opposite side length from our theta angle. So now moving on to our second trig function, we have cosine. So we already dealt with sine, which is so, and the opposite of that, which is cosecant. So we know we have opposite and hypotenuse. Moving on to cosine. Cosine is co. So we have cosine, which is our adjacent side length over our hypotenuse. So lastly, we have our third trig function, which is tangent. And tangent is our TOA. So we have ca, and then TOA. So TOA is opposite over adjacent. Opposite is that side length that is opposite from our theta angle, and adjacent again is that side length that is adjacent from our theta angle. And so the inverse of tangent is cotangent. And so the way we write that fraction is just the complete opposite of what you see above that. So instead of O or opposite over A adjacent, it's A over O. So here we have our right triangle, and I zoomed in a bit, and I'm also labeling the side lengths in relation to our theta angle, which I have an arrow pointing to, and I labeled in red. So again, when we are looking at that theta angle, we know that the opposite side length from our theta angle is the side length with the 6. So I label that opposite with O in quotes. Right beside that, or right next to that, adjacent to that, is our adjacent side length, which I labeled adjacent in red, and in quotes put A. And then our hypotenuse, like I stated, which is always, no matter where our theta angle is, our hypotenuse side length is always the longest side length. It's always that slanted side length that you'll see in a right triangle. So I'm going to label that hypotenuse, and then again write in a letter H just to represent that. Now that you can clearly see, and I'm circling in red, our trig functions and what they mean or what they signify as far as the side lengths that we need in our right triangle. So for again, soca, toa, and the inverse functions beneath side length, I hope this makes it a lot more clear so that we can move on and finally start solving for all 6 trig functions. So for cosine of theta, looking at that note I drew in, we know cosine of theta, cosine is ca, and so ca toa, and ca is a over h. So a is our adjacent, and h is our hypotenuse. As you can see, I'm also highlighting in the diagram. So we know a is 8 according to this triangle, and our h, which I also highlighted in a very light pink, so you may not be able to see that, is 10. So we have 8 over 10. However, we cannot leave our answer just like this because if you may notice, we can simplify this fraction further. 8 and 10 are both divisible by 2. That is their GCF. So we take that GCF of 2, we divide it by the numerator and denominator, and what we get is 4 over 5. So once we have 4 over 5, we know that 4 and 5 do not have a greatest common factor or a factor in common, so we know that that is a fraction in its simplest form, and that is our final answer, 4 over 5. So 4/5 or 8/10, however you prefer or are required to write it, would be cosine of theta. Now we're going to solve for the opposite. So we are going to solve for secant of theta. So secant of theta, if we look at that chart ahead, we see that secant of theta is literally just the opposite. It's the reciprocal or just a flipped version of that fraction. All right, so moving on to our second trig function, or I guess technically our third one, we are now going to solve for sine of theta. So again, using that that note, the notes I wrote up there, circled in that red cloud, we know that sine is our so in SOHCAHTOA, and our so is O over H, which is opposite over adjacent. So looking back at the triangle, our O is our opposite side length, and our opposite side length, its value is 6, and our hypotenuse is 10. We have 6 over 10, so yeah, again, we can simplify this fraction. We see that 6 and 10 have a GCF, or greatest common factor, of 2. Both numbers are divisible by 2. We can simplify this fraction, so if we do that, let's see what we get. So if we divide 6 by 2, we get 3, and when we divide 10 by 2, we get 5. So the opposite of sine of theta would be cosecant of theta. And again, we don't have to go through that process again of solving anything or simplifying. We can just take that fraction 3 over 5 and write it as its reciprocal for cosecant of theta, which is just, instead of 3 over 5, 5 over 3. Now, for our second to last trig function, we want to find tangent of theta. So again, referencing my notes that I wrote above, tangent is our toa and SOHCAHTOA, which is opposite over adjacent. So if we look at the triangle diagram, our opposite O is 6, like we mentioned earlier, and then adjacent, our adjacent side length A value is 8. So we have 6 over 8, and again, I'm just labeling that to make it clear. And once again, we have a fraction we can simplify because we see two numbers that are are not only even but divisible by the same number and have a common factor. Its greatest common factor is 2, and so when we take the greatest common factor, the GCF, and divide it by the numerator and denominator, we get 3/4. And now we can solve for our last trig function, which is just the opposite of tangent of theta. The opposite of tangent of theta, as you can see in the notes above, is cotangent of theta. Again, we don't have to go through that process of solving. We can just take that fraction and rewrite it in flipped form. So instead of 3/4, we have 4/3. So 4/3, 4/3 is cotangent of theta. And now we've solved for all 6 trigonometric functions of theta according to this right triangle.
Wait, before you leave, go ahead and check out these lessons up above. You can watch this lesson, or you can watch that one, or you can watch both. Oh, and while you're at it, please do me a huge favor and subscribe to my YouTube channel. You can do so by clicking out of this video and hitting the subscribe button. Thank you so much. Bye.